What's up guys, welcome back to a new video where we learn about mathematics and physics by doing exercises step by step. In this particular video, we'll be focusing on systems of linear equations and how to solve them. As always, these exercises will start out very basic, but will get progressively more complex towards the end, so feel free to skip around according to your own level. The timestamps can be found in the comment section below. Now, before we dive into the first exercise, I want to mention that if you have any suggestions for future videos, just leave your topic of choice in the comment section below, and you can be sure that I will make a video on that specific topic. So let's dive into the first exercise. The first exercise, like I said, is very basic, but it just shows you how to solve these exercises in general, so that you will be able to tackle more complex exercises. As you can see, we have two equations here, and what we want to do is to find an expression or a number for x and y in order that these two equations are true, so that these two equality signs are indeed true. In this particular warm-up exercise, we already see that x has to be equal to 2, so we don't have to do any manipulations to get to this result. What we then do is to substitute this x into the equation in order to get a number for y. How does this work? So we have y is equal to 2 times x, and x is 2, so 2 times 2 plus 3, which is of course equal to 7. And well, as fast as that, we already have our result. We already solved the exercise. So we have y is equal to 7 and x is equal to 2. To see whether we made any mistakes, we can always check our answer by filling in our result, so x is equal to 2 and y is equal to 7, in our initial set of equations. And if we didn't make any mistakes, these equality signs should be right. So the first one is very easy. We just replace x by 2, and we already have, well, 2 is indeed equal to 2. Then in the first equation, this x also gets replaced by 2, which becomes 2 times 2 plus 3 is 7. And if we now replace our y with the result that we got, which is that y is equal to 7, we see indeed that these equality signs hold, because 7 is equal to 7 and 2 is equal to 2. Let's go to the next exercise. In this exercise, we have two equations. Y is equal to x plus 6, and the second equation is x is equal to minus y minus 2. And in this particular example, we already see that we don't have an immediate answer for x or y, meaning that we will have to do some work in order to get x and y. The first step is to rewrite this first equation as a function of x. So we want to rewrite it such that it says x is equal to something. We can do this quite easily by taking this 6 and putting it on the other side. So we subtract 6 from both sides of the equation. And then we get y minus 6 is equal to x. And now we already have an expression for x, but in this expression for x, we still have this y. The next step is to take this expression that we obtained for x and substitute it into this second equation. And then we will get an equation where only y is present. Let's see how this goes. So this equation can be written as x, which we will write as y minus 6. So y minus 6 is equal to this right-hand side of the equation, minus y minus 2. This equation can then be rewritten as y is equal to something by adding y to both sides of the equation, because we have a y here and a y here, and we want to get this y to that side of the equation. This results in y plus y minus 6 is equal to minus 2. And if we rewrite this even further, we get 2 times y is equal to minus 2 plus 6, because we moved this minus 6 to the other side of the equation. And then we can rewrite this even further. So we get y is equal to 4 divided by 2, which is equal to 2. And we have our solution here. We have y is equal to 2. Now, we are not done at this point, because even though we have an expression for y, so y is equal to 2, we still do not know what this x here is. However, we can use the result that we now obtained, this y is equal to 2, and plug it in this expression for x. And so then we will get our result for x. So we have x is equal to y minus 6, which is equal to 2 minus 6 is minus 4. We see now that x is equal to minus 4. So we have our second result here, x is equal to minus 4. And now we are done. We have gotten our result, which is that x is equal to minus 4 and y is equal to 2. And again, to see whether we made any mistakes, we can fill our result back into our exercise and see whether these equality signs are indeed true. Let's first replace all the x's with minus 4s. Let's first remove all of the x's and replace them with minus 4. So this x becomes minus 4, and also this x becomes minus 4. Now let's remove all of the y's and replace them with 2's. This y becomes a 2, and also this y gets removed and becomes a 2. So what do we see now? We see that indeed minus 4 plus x is indeed equal to 2, and minus 4 is indeed equal to minus 4. So we did not make any mistakes. Let's go to the next exercise, where we have x is equal to 3 times y minus 5. And the second equation that needs to be true is 5 is equal to x minus y. And again, we need to find x and y such that these two equations are true. Again, just the same procedure as before. We rewrite this first equation as x is equal to something. And we see that we are in luck here because we already have x is equal to 3y minus 5. So we don't have to do any more calculations here. So we have an expression for x as a function of y. This expression for x can then be used to substitute in the second equation. And then we get that 5 is equal to x, but x is equal to 3y minus 5 minus y. And this minus y is just, well, copied over. And now we can rewrite this equation. So we get 5 is equal to 3y minus 5 minus y. So we can rewrite it even further. 5 is equal to 3y minus y is 2 times y. 2 times y minus 5. Rewriting this even further, we get our final result that 2y is equal to 10, because this 5 got moved over there. And our final result then is, of course, that y is equal to 5, because we divide the two sides of the equation by 2 and we get our final result. Y is equal to 5. All right, so we are halfway there. What we do now is use this expression for y and plug it in here in our first equation to get an expression for x. How does this then look? We get x is equal to 3 times y minus 5, which is equal to 3 times 5, because y is equal to 5, minus 5, which is equal to 15 minus 5, which is equal to 10. And we have our result already that x is equal to 10. So our complete result is that x is equal to 10 and y is equal to 5. And to see whether we made any calculation mistakes, let's again check our result and fill our result into our initial exercise. So first we remove the x's and fill in 10. So this x disappears. Here this x also disappears and we rewrite 10. Next, we erase all the y's and we fill in 5 because we found that y has to be equal to 5. So this y also removes, so we get 3 times 5. And now let's see if these equations, these equality signs here, are indeed correct. So we get 3 times 5 minus 5 is 15 minus 5 is indeed 10. So this is already correct. And we see that 5 is indeed equal to 10 minus 5. So we didn't make any mistakes, and we can be sure that our result is correct. Let's go to the next exercise, which somewhat holds a surprise for us. So we have 0 is 5 times y minus 1/2 times x. And the second equation is x is equal to 3 times y minus 5 times x. And again, what are x and y such that this equation is true? The first step, as always, is rewriting the first equation as a function of x. So x is equal to something. To do this, we first take this term and we bring it to the other side of the equality sign. So we have 1/2 x is equal to 5 times y. And then we multiply both sides by 2. So we get x is equal to 10y. And this is our first step of solving this system of equations. Then we take this expression of x and fill it in our second equation. So we get that x is equal to minus 10y. So we get that x is equal to 10 times y. So this is what we fill in here and here. So we get x, which is 10y, is equal to 3 times y, which we just copy, minus 5 times 10 times y, because x is equal to 10 times y. Rewriting this, we bring all of the expressions with y to one side of the equality sign. So we get 10 times y minus 3 times y plus 50 times y is equal to 0, because there's actually no other term here without a y in its expression. And well, you might see this coming already, but we eventually get 75y is equal to 0, which of course is only possible if y is equal to 0. And we already have our first result, so y has to be equal to 0. Now, as always, we use this expression for y to get an expression for x. And we see that x is equal to 10 times y, which we got from the first equation. But since y is equal to 0, then x also has to be equal to 0. So we get that x is also equal to 0. And our solution is just x is equal to 0 and y is equal to 0. Now, it doesn't take very long to realize why exactly this is, because if we look at the initial equations, then we see that in each term, this is a term, this is a term, this one and this one, in each term we have either a x or a y. So then it's very straightforward that filling in 0 in all of these terms gives us simply 0 is 0 and 0 is 0. So the solution x and y is equal to 0 is very obvious from the fact that all of the terms in our initial problem had either an x or a y. And this can be used as a kind of shortcut. When you're solving exercises and you come across an exercise like this, you immediately know that the solution will be 0 and 0. Let's now go to the next exercise, which is the first one of 2 more difficult exercises. But if we just use the method that we have been using all along, we will be sure to get the right result. And these are the 2 equations. And we need again to find x and y such that these 2 equations are true. And as always, we start with the first step to rewrite this first equation as a function of x. So we get that 2x is equal to y plus 4. Or we can rewrite this even further, that x is equal to y plus 4 divided by 2. And now we already have an expression of x as a function of y. This can be used to fill in our second equation, which then becomes 4 times, and now we fill in x, which is y plus 4 divided by 2, minus 6 is equal to y minus 4. And now the hardest part is already done, and we simply rewrite this equation as a function of y. So we get that 4 times y over 2 plus 4 times 4 over 2 minus 6 is equal to y minus 4. Rewriting this, we get 2 times y plus 8 minus 6 minus y is equal to minus 4. And in this step, I also brought this y to the other side of the equality sign. Taking all the y's together, we get 2y minus y. So we get y is equal to minus 4 minus 8 plus 6. And what I did here was take this 8 and this minus 6 to the other side of the equality sign. And now we are simply there. So we get that y is equal to minus 6. And this is our first result already, but we're not done yet, because now we fill in this y is equal to minus 6 in the equation for x that we found from our first equation. And we get that x is equal to y plus 4 divided by 2. And since y is minus 6, x is minus 6 plus 4 divided by 2, which is simply equal to minus 1. So our second result is that x is equal to minus 1. So our complete result is x is equal to minus 1 and y is equal to minus 6. And to be sure that our solution is correct, so that we didn't make any mistakes, we again check it by filling in these solutions into our initial equation and seeing that these equality signs are indeed true. A first step is to remove all the x's and replace them by minus 1. So this x becomes a minus 1, so we get 2 times minus 1. This x also becomes minus 1, and we have to be careful here that we really take along with us the minus signs. Then the next step is to replace all the y's with minus 6. So this y becomes minus 6, and also this y becomes a minus 6. And now it's just basic arithmetics to see whether we did or did not make any mistakes. And it's looking good because we have minus 6 is equal to minus 2 minus 4, which is indeed equal to minus 6. So this first equation already holds. Then we get minus 6 minus 4 is minus 10. And also here we get minus 4 minus 6 is minus 10. So we didn't make any mistakes, and we can be sure that our result is indeed the correct result. To finish off, let's go to the last exercise, which is the most complex one of them all. We get 3 times x minus 5 times y is equal to 2 times x plus 1. And for the second equation, we get 4 times x plus y is equal to 2 times y. So these two equations might look quite intimidating. However, if we just do the same steps as before, we will be certain to get a right result if we do not make any stupid little calculation mistakes. So let's just do this. The first equation we rewrite as x is equal to something. And how do we do this? Well, we get 3x minus 2x, because this 2x we get to the other side of the equality sign, is equal to plus 5 times y plus 1. Or if we rewrite this, we get x is equal to 5y plus 1. And we already have our expression for x from the first equation. This expression can then be used in the second equation to get a number for y. Let's see how this goes. So we have 4 times x plus y, and x is 5y plus 1. So we have 5y plus 1 plus y, and the second plus y just is a copy of this one, is equal to 2 times y, which is basically the right hand side of this equation. Rewriting this, we get 4 times 6y plus 1 is equal to 2 times y. Or, written differently, we have 24y plus 4 is equal to 2y. Rewriting this, we get 22 times y is equal to minus 4. Or, written differently, y is equal to minus 2 over 11. And we already have our first result, which is that y is equal to minus 2 over 11. This can be used in our first equation again, where we got an expression for x as a function of y. But now this y can just be filled in as minus 2 over 11. So we get that x is equal to 5 times y plus 1, which is 5 times minus 2 over 11 plus 1. Or it is equal to minus 10 over 11 plus 1. And rewriting this, we get minus 10 over 11 plus 11 over 11, which is simply 1 over 11. So we get that x is equal to 1 over 11. And our final result thus is x is equal to 1 over 11 and y is equal to minus 2 over 11. And this is our final result for this quite complex looking exercise. Which I leave to you now is to check whether this is indeed the correct result. By filling in x is equal to 1 over 11 and y is equal to minus 2 over 11, in our initial exercise, we will see that these equality signs are indeed true and that we didn't make any mistakes. This brings us to the end of this session, and I hope that you are now more confident in solving systems of linear equations. If you have any questions or suggestions about future topics, just leave a comment in the comment section below. I still read all of them. If you really like the video, don't hesitate to give it a thumbs up, because this makes it more likely that other people will be finding these videos. If you want to get notified for future releases, hit the subscribe button. And with that, I see you guys in the next video. Bye.